Hi folks, we're going to take a look at number 11 from page 83. So here they want us to find the values of x such that the tangent to this curve is parallel to the given line here. So we know that if the tangent needs to be parallel to this line here, that they're going to share the same slope. So I'll use this line to find the slope. All right, so 16y, bring the x to the other side, and the 3, and then I'm left with y equals negative 1 over 16x minus, I actually don't care what's there because the only thing I care about is the fact that the slope of the line I'm looking for has to be the same as that one, so it's got to be equal to negative 1 over 16. Now, since the line I'm looking for is tangent to this function here, it means that the slope of the tangent is also given by the derivative of the function. So now I'm going to find the derivative of this function. Okay, in fact, I'll start by rewriting it. Okay, just to make it really clear what I'm doing. So I've got this constant of 3. That's not going to be a problem. I'm going to rewrite the 1 over cube root of x as x to the negative 1/3. Okay, that's going to make taking the derivative much easier. So now I'll take the derivative. All right, so constant of 3 times the derivative of x to the negative 1/3 is just going to be negative 1/3. X to the negative 1/3 minus 1 is going to be negative 4/3. All right, and we can even simplify that a little. So 3's go, so I'm left with negative 1 over x to the 4 over 3. All right, so now I need to determine which x values are going to give me a slope of negative 1 over 16, so I'm just going to equate these two. All right, so that means that negative 1 over x to the 4 over 3 has to be equal to negative 1 over 16. All right, and this is a fairly easy equation to solve because I could divide both sides by negative 1 and the negatives disappear. And now I'm just going to do a little cross multiplying. So I have x to the 4/3 is equal to 16, or take the reciprocal of both sides. We'll achieve the same result. All right, and now in order to isolate x, I'm going to take both sides to, well, exponent 3 over 4. So that when I apply my exponent rule and multiply, this just gives me x to the 1. So I'll have to do the same thing here. 3 over 4. So x is going to be equal to, and it makes more sense to take the 4th root of 16 first and then cube it instead of first cubing 16 and then taking the 4th root. That's much tougher. So here, 4th root of 16 is 2. 2 cubed is 8. And there's my final answer. Okay, I'll go back and check. Since they're only looking for the x value, I don't need to find the equation of this tangent line. I don't need to find the point. Okay, if that's what they were asking, I would continue on. But all they want is the x value. So just to recap here, the line that I'm looking for, the tangent I'm looking for, is parallel to this given line here. So I use this line to find the slope, which is going to have to be the same. Then I use the fact that since the line is tangent to this curve, I can also use the derivative to find the slope of the tangent. And by equating them, I can then determine which x value this occurs at. Okay, that's it for this one.